So today we're going to be talking about matrices. Matrices are a way that mathematicians devised to talk about big equations in a way that required a whole lot less writing. The kind of modern equivalent to matrices is a spreadsheet. So essentially what we're doing today is the kinds of things you do in a spreadsheet by hand, just to show you, just for a little bit of context. We won't be going anything too large or too complicated, so don't panic. It should be okay. But first, we just have to know how to talk about matrices. First, a singular matrice is a matrix. So matrix is singular. And matrices is plural. Before we go any further, it becomes necessary to point out that matrices are frequently named. For example, on the right, I have two different matrices. I have A, which contains numbers, and I have matrix B, which contains letters. It becomes helpful to talk about them in that context, just so that you're not trying to say a whole bunch of numbers every time you do it. Another thing I want you to remember is the difference between a row and a column. A row is horizontal, and a column is vertical. So for example, in matrix A, the first row is 1, 2, 3, 4, but the first column would be 1, 5, 9. We end up using the terms rows and columns a lot with matrices, so make sure we understand the difference. A very common thing that we talk about with matrices is the idea of its dimension. Dimension isn't that hard to understand. It's the number of rows and the number of columns. You write it in such a way so that it's going to be row. You put an X in the middle, which means by, which it's called by, and then column. So for example, matrix A has 1 row, 2 row, 3 rows, and it has 1 column, 2 columns, 3 columns, 4 columns. So it's a 3 by 4 matrix. Similarly, B has 1 row, 2 rows, 3 rows by 1 row, 2 rows, 3 columns. Notice matrix B has the same number of rows and columns, so this is what we call a square matrix, meaning it's got the same number of rows and columns. We'll get to that in a second. But for now, we're going to talk about a very important axiom or rule. For two matrices to be equal, every element must be the same. Now I know what you're thinking. What's an element? An element is an individual entry in a matrix. So for example, if you look over here at A, you'll notice that A has a whole bunch of elements of numbers, and B has elements which are letters. We talk about them in this kind of way. You write the matrix name, and then you're going to talk about the row and the column. So for example, here in A, if we're looking at A, row 3, element 4, that would be going down to the third row and over to the fourth element in the fourth column. That will be 12. Take a second, see if you can figure out what B to 3 would be. Well, you'd go down to the second row and over to the third column, so it would be F. So that's how you describe an element. It's just the individual things inside of the matrix. Let's just look at some matrices really quick. I'm just going to do a 2 by 2 matrix. Let's go 1, 2, 3, 4. What we are saying by this axiom, for two matrices to be equal, every element must be the same. It logically follows that if we want this matrix to be equal, the thing that has to go in the red slot must be a 4. Similarly, if we were to do this matrix, we'll go 1, 2, and this is x over 2. Well, no, we'll get rid of that over sign. That's a mistake. X must equal 1. Let's try an example problem from your homework. Let's look at number 9. Negative 4x minus 3 over 6y in a matrix equals negative 3x and negative 2y plus 16. We are to find x and y, the values of them. So, if these matrices are going to be equal, then this element must equal this element. Or we could rewrite it to look like this. Negative 4x minus 3 equals negative 3x. Well, we can solve that really quick. We add 4x to both sides. We get negative 3 equals x. Similarly, we can do the same thing with y. 6y equals negative 2y plus 16. Well, we add 2y. We get 8y equals 16 when y equals 2. Those are the values which makes the two matrices equal to each other. All right, we'll do just one more example problem from your homework. This is number 13. You can buy tickets in advance or at the door. At the door, okay, we're going to pause right there really quick. So how many rows are we expecting? Well, we have one row here, the in advance row. We also have the at the door row. Let's read on. At the door, children are $8, students are $14, and adults are $20. Well, we have 3 different categories. That could be 3 different columns. I'm going to put C for children, S for students, and A for adults. Well, now we just kind of enter in the values. At the door, children are $8, students are $14, and adults are $20. In advance, children are $6, students are $12, and adults are $20. And there's our answer. Notice what I care about for your answer is the matrix only. You do not have to have the labels. You do not have to have any of the words that go with them. I solely care about the information. That's all you need to do with it. You don't need to add any other words or anything else. If, for example, you chose to write this in such a way so that it was, say, like adults, children, students, but the numbers were in a different order, but were still in the right columns, that would have been totally acceptable. You can move the columns around in a matrix so long as all of the digits stay in the same place. Same thing with the rows. You can move the rows around and write things in a slightly different order, but get the same idea and the same information communicated. As always, let me know if you have additional questions.